Hello guys, today we are going to do the second order differential equations with our undetermined coefficients and aka the non-homogeneous second order differential equations. And you can see the right hand side side, so it is non-homogeneous. And here I'm going to solve this differential equation by using our inversely operator method. First, we are going to find the homogeneous solutions to this differential equation first. First, look at the degree. I'm going to let this equal to m squared and then plus COY prime. COY prime, so therefore this COM, and then plus our zeroth derivative, therefore this plus 1 is equal to 0. And then we minus 1 on one side and then take a square root, and don't forget about the plus or minus sign. You can get m, which is equal to plus or minus I. I can write this as 0 plus or minus I. Therefore, you can get our complementary solutions, which is equal to e to the power of 0x, and then times c1 cosine 1x. You can see this 1i, therefore this 1x. So this cos x plus c2 sine 1x, therefore this sine x. And then e power of 0, which is 0, therefore e power of 0, which is 1. Therefore 1 times this entire thing, you can get c1 cosine x plus c2 sine x. These are our complementary solutions. We only find the homogeneous part. And then here, to find our this particular solutions, we are going to use our inverse operator. Yes, this force to use. We can write this as D² plus 1 and then time y, which is equal to sin x. And then our y, which is equal to 1 over D² plus 1 sin x. And okay, we have a formula. You know, whenever you see sin x, you are going to do it with the inverse operator. You know that D², yes, 1 over f of d, and then sin ax. You know that D² is going to be equal to negative a². But however, when you try to put our negative 1, what's this negative? We need a negative sign. This D², which is our sine 1x, you can see this sine 1x, that a, which is equal to 1, therefore this is negative 1 squared, and then plus 1. And then negative 1 plus 1, which is 0. When the denominator is equal to 0, we have to use our standard formula. Our standard formula of this 1 over D² plus a² sine x. How can we remember this? First, you are going to integrate sin x. You are going to get negative cosine x, and don't forget to divide it by a. Right. Therefore, you can get negative 1 over a cosine x, and then we are going to add our extra 1 over 2 times x, like that. Therefore, the formula becomes negative 1 over 2a x cosine ax, like that. And then for cosine, pretty much the same. Integrate this cosine x, you can get 1 over a sine x, and then multiply by 1 over 2a. No, multiply by x over 2, just like this, 1 over x, which is multiply by 1 over x. And then therefore you can get the answers, which is equal to 1 over 2a x sine x. This is the standard form. When you get D² plus a² is equal to 0, you have to use this formula, these two formula. Therefore, we are going to look at this a. Our a here, which is, you can write this one as 1 squared, therefore this 1 over 2 times 1, which is 1 over 2 in front, and then x times our, this is our sine, therefore this negative sine, x times cosine 1x, which is cos x. Therefore, you can get this is negative 1 over 2 x cosine x. Therefore, this is our particular solutions. Therefore, we can get our y, which is yc plus our yp. This should be our yp. particular solutions. Therefore, this is u to yc plus yp, which is c1 cosine x plus c2 sine x minus 1 over 2x cosine x, like that. Therefore, this is our solutions, and thanks for watching.